We tend to think of the universe's history as this vast, random collection of events. But what if it's not random at all? What if, for the last 13.8 billion years, everything has been following a script, a hidden plot, where the pace of change just keeps getting faster and faster, pushing everything from simple beginnings toward mind-boggling complexity? I know it sounds like science fiction, right? But the crazy thing is, when you start to look at the evidence, you find these hints, this deep logic that seems to connect the birth of stars to, say, the invention of your smartphone. So in this explainer, that's exactly what we're going to do. We're going to become cosmic detectives and hunt down the clues. So we're on the lookout for this hidden pattern, this thread of accelerating change that runs through cosmic history, life on Earth, and even our own society. And our investigation? Well, it's got to start with the most basic ingredient for everything: energy. All right, so clue number one. This one is all about the engine that powers everything. From giant stars to bustling cities, how do complex things stay, complex? It turns out the more intricate something gets, the more energy it absolutely devours. And scientists have a really cool way of measuring this. It's a bit of a mouthful, but it's called energy rate density. The easiest way to think about it is like a metabolism for everything. You know, how much energy something burns per second, per pound, just to keep the lights on. So a galaxy, super low metabolism, just kind of chills there. But a living thing, its metabolism is way, way higher. And when you start comparing these metabolisms across the history of the universe, whoa, a pattern just jumps right out at you. So this astrophysicist, Eric Chasin, he actually did the math. He calculated this energy metabolism for all sorts of things. And check this out. Galaxies are way down here, super low. Then life pops up, and boom, the metabolism is much higher. And modern society? It's completely off the charts. It's an undeniable trend. The more complex something gets, the more energy it burns, and it burns it more intensely. But here's a fascinating twist. It's not just about brute force burning more and more power. It's also about getting smarter. Think about your brain. It is arguably the most complex object in the known universe, and it runs on just 20 watts of power. That's less than a dim light bulb. Now, try to get a supercomputer to do what your brain does. It would need megawatts, a staggering amount more power. So as complexity grows, it's not just getting more powerful, it's getting incredibly efficient. Okay, let's move on to our second clue. And this one is a bit of a mind bender. It's all about a weird, backward relationship between the size of things and the space they need to develop. You'd think, to build big things, you need big building blocks, right? Nope. The universe seems to do the exact opposite. This idea comes from a thinker named Eric Janschwich, and it's this kind of cosmic zoom-out effect. To create smaller, more complex things, you actually need a bigger playground. Think about it. Tiny little quantum fluctuations needed the entire vast early universe to grow into galaxies. Single cells, they needed a whole planet to evolve. And today's microchips, these tiny little marvels, they can only exist because of a massive global network of trade, research, and communication. The more complex and tiny the innovation, the bigger the stage it needs. All right, our third clue might be the strangest one yet. It connects the giant, sweeping story of evolution, we're talking billions of years, to the development of a single person, you, in just one lifetime. It's almost like all of cosmic history is leaving an echo right inside our own bodies. So a researcher named B. Xtig noticed something incredible. The sequence of big evolutionary milestones over eons. It's often mirrored, step for step, in the way a single organism grows up. It's like the deep past isn't just past, it's a living blueprint for the present. Check out these examples, they're wild. So, specialized animal tissues first evolved more than 500 million years ago. Today, that exact same process unfolds in the first few weeks when an embryo develops. Or how about this? Our ancient ancestors first stood up and walked about 2 million years ago. Today, a toddler relives that incredible achievement around their first birthday. It's like evolution's greatest hits are replayed on a super fast timeline inside each of us. Okay, let's take a step back. So we've got our clues. Clue 1, a rising energy metabolism. Clue 2, this weird shrinking scale of innovation. And clue 3, these ancient echoes of evolution playing out in our own lives. So where's this all going? What's the big picture here? Well, it turns out all three of these clues point to the exact same thing. A single, startlingly simple mathematical pattern that seems to govern the pace of change across all of history. And it's not a straight line. It's not even the exponential curve we hear so much about. It's something faster. It's a pattern called hyperbolic growth. And here's the key difference. With normal exponential growth, think of money in a savings account, maybe it doubles every 7 years, that doubling time stays the same forever. But with hyperbolic growth, the doubling time itself gets shorter. So something doubles in, say, 1,000,000 years. Then the next doubling only takes 500,000 years, then 250,000. The acceleration is, well, it's accelerating. It's like a runaway train that's constantly adding more engines. And this is exactly what a researcher named Panov discovered. He mapped out all the major turning points in the history of life, and the time between them is shrinking, big time. We're talking billions of years between the first life and the Cambrian explosion. Then it's only a few 100 million to the dinosaurs. Then just a few million to our hominid ancestors. Then tens of thousands of years to the first art. Then just thousands to farming. Then hundreds to the scientific revolution. You see the pattern? The whole thing is speeding up. And if you take that curve and just extend it into the future, you land on a very specific date. Panov's math, tracking this trend across billions of years, points to a singularity right around the year 2027. Now, hold on. Before your mind goes to doomsday scenarios and Hollywood blockbusters, let's be super clear about what that word actually means in this context. Yeah, that date does not mean it's the end of the world. The word singularity here is a scientific term, and it has nothing to do with what you've seen in the movies. It's just a mathematical term for a phase transition. The best analogy is boiling water. At 99 degrees, it's just really hot water. It follows the rules of being a liquid, but at 100 degrees, boom, it becomes steam, a totally new state with new rules. This singularity is like that. It's the point where this old pattern of hyperbolic growth mathematically breaks down. It has to stop. And a new set of rules, a new pattern of change, has to begin. It's a transformation, not an apocalypse. So this whole incredible story of acceleration is fueled by those clues we uncovered. You've got more complex systems burning more energy faster. You have ever larger environments allowing for ever smaller, more complex breakthroughs. And maybe most crucially, learning is cumulative. The information we gain in one era becomes the launch pad for the next, which is the very engine of acceleration. So what this all suggests is that we are living through a truly profound moment. The culmination of a pattern that's been building for nearly 14 billion years. The old runaway train of history is pulling into the station. A new journey is about to begin. And this feeling of rapid, accelerating change, it's not just in your head. It's a real, measurable, cosmic trend. So the big question this leaves us with is, what happens next? As we stand here at this incredible turning point, what role are we going to play in writing the next chapter of the universe's story?